Hello viewers, in today's lecture we are going to integrate functions like um, uh, px plus q divided by ax square plus bx plus c. Here the numerator is a linear uh, polynomial while the denominator is a quadratic polynomial. Clear? So here we are going to study the technique to integrate a function um, fx which is a combination of linear and quadratic polynomial um, in this manner. Clear? So I am taking here one important example, and here we have to integrate the function 2x minus 5 divided by x square minus 6x plus 3. So viewers, here this is the linear polynomial. The numerator is the linear polynomial and the denominator is a quadratic polynomial. Clear? So here what we will do, will express this linear factor 2x minus 5 as a product of some constant multiplied by the derivative of the denominator and we add a constant b. Clear? So here we have the linear factor is equal to a times the derivative of the denominator, or we can say this is the quadratic function plus b. Clear? Or we can say that if this is the linear factor, then the numerator can be expressed as a times the derivative of the denominator plus another constant b. Clear? So we can remember any of these two expressions. Clear? So this is the linear factor, this is the quadratic factor, and a and b are two constants. Clear? Okay, so let us solve this expression, and here we have 2x minus 5 is equal to a times derivative of x square minus 6x plus 13 plus b, and our aim is to find these two constants. Clear? So this can be written as 2x minus 5, this is a times the derivative of x square is 2x minus 6. Here we have the derivative of x is 1, so we have 6 ones are 6. Derivative of 13 is 0, being a constant, and we have plus b. This can be written as 2ax and plus b minus 6a. Clear? Now if we compare both the sides, what we will get, we'll have 2 is equal to 2a, comparing the coefficient of x, so we have a is equal to 1, and comparing the constant term on both sides, b minus 6a is equal to minus 5, so we have b minus a is 1, so 6 times of 1 minus 5, so we have minus 5 plus 6, and we have 1. Clear? So this is the value of uh, b. So we have a is 1, b is 1. Clear? Now this integral I can now be expressed as this 2x minus 5 can be written as a times 2x minus 6 plus b divided by x square minus 6x plus 13. Clear? Now viewers, from here we'll write this integral, or let us first substitute the values of a and b here. So we have 1, this is 2x minus 6, then we have 1 here, and we have x square minus 6x plus 13 and dx. Clear? Now let us separate this expression, and we write 2x minus 6 divided by x square minus 6x plus 13 dx plus integral of we have 1 over x square minus 6x plus 13 dx. Okay, now viewers, here we have two integrals. This is I1, let us say this is I2. Clear? Now this integral I is now equal to the sum of these two integrals, and let us calculate the values of I1 and I2 separately. Now I1 is 2x minus 6 divided by x square minus 6x plus 13. So here we observe that the numerator is the derivative of the denominator. Clear? So we can directly write this integral as log of x square minus 6x plus 13 plus c1. Clear? Because we know that if we have an integral, say if this is f prime of x and this is f of x dx, and if the numerator is the derivative of the denominator, then it can directly be written as log of f of x plus c. Clear? We can also evaluate this integral by putting t is equal to x square minus 6x plus 13. Then we have dt is equal to 2x minus 6, dt by dx is equal to 2x minus 6, so dt is equal to 2x minus 6 dx, and then we have I1 is equal to integral of dt divided by t, which can be written as log of t plus c, and if we substitute the value of t as x square minus 6x plus 13 plus c, so this and this are same. Clear? So we have the value of I1 as log of x square minus 6x plus 13 plus c1. Now let us calculate the integral I2. Now the integral I2 is we have 1 over x square minus 6x plus 13 dx. Now we have already discussed the method to calculate the integral of a function which is of the form 1 divided by ax square minus ax square plus bx plus c, and from our previous knowledge we know that to calculate such type of integrals, we have to express the denominator in the form of completion of squares. So let us do it, and we have this is dx, and we can express this quadratic polynomial in this form, and this is x minus say 3 square. So we have x square, then 2ab, that is minus 6x, and then we have plus 9. So in order to eliminate that 9, we should subtract minus 9, and here we have plus 13. Now this can be written as dx divided by x minus 3 square plus 13 minus 9 is 4, so this is 2 square. Clear? Now let us put say t is equal to x minus 3. So where we have dt is equal to dx. So therefore this integral I2 is given by dt divided by t square plus 2 square, and this has reduced, this integral has reduced to this form, that is form 3. Clear? So here we have this form 3. So the integral of 1 over t square plus 2 square is 1 over 2, and this is tan inverse t divided by 2 plus c2. Now we can write it as half multiply tan inverse, and t is x minus 3 divided by 2 plus c2. Clear? So where's now we have calculated the value of I1 and I2. Therefore the complete solution of the given integral I is I1 plus I2, and I1 is log of x square minus 6x plus 13 plus c1, and I2 is half tan inverse x minus 3 divided by 2 plus c2. Clear? Now where c1 and c2, the sum of c1 and c2 is some other constant, say c. So therefore I can be written as log of x square minus 6x plus 13 plus half of tan inverse of x minus 3 divided by 2 plus c. So this is the required integral of the given